Welcome to qnawire.
All right. So for this problem, we are looking at the exercise 31.14, which is over here. So we utilize the values in this problem, the resistor, the inductor, and the capacitor, and also in the source. Yeah. So for part A, we want to find out the impedance of the circuit. Part A, the impedance. So the definition of the impedance is R squared plus omega L minus 1 over omega C squared. And you plug in the values. R is 200, omega is 250, and L is 0.4, C is 6 microfarads. And if you plug in these values, you see that Z equal to 600 ohms. So for part B, the current amplitude in this circuit. The current amplitude is simply V over impedance Z. And V is given in this problem. It's 30 volts. And Z is 600. So just 30 over 600 equal to 0.05 amperes. Okay. And for part C, what is the phase angle of the source voltage with respect to the current? So the phase angle cosine phi equal to R over Z. R is 200 and Z is 600. So equal to 1 over 3. So we can solve for this phi equal to plus or minus 70.5 degrees. And the other one is does the source voltage lag or lead to current? To figure this out, we need to compare the reactance of the inductor and the capacitor separately. So the reactance of the inductor is omega L. Omega is 250, L is 0.4, so omega L is 100 ohms. 100. And the reactance of the capacitor is 1 over omega C, which equal 667 ohms. So apparently, the reactance of the capacitor is greater than the reactance of the inductor. So in that case, the current leads the voltage, all right? So equivalently, the voltage lags the current in this case. And for part D, what is the voltage amplitude across the resistor, inductor, and the capacitor? So across the voltage across the resistor is VR equal to the amplitude is over here, I times R. So R is 200, so this is 10 volts. And VL is I times omega L, which equals to 5 volts. VC is I times 1 over omega C, which is 33.3 volts. Okay. And for part E, so explain how it's possible that the voltage amplitude across the capacitor to be greater than the voltage amplitude across the source. This is actually possible in the RLC circuit because typically, so we have this R, we have the L, we have the C in the circuit. So if the potential difference for the capacitor, so for example, this is greater and this is lower, and in this case, this will be lower and this side will be higher. So this plus means the potential at this point is higher. The potential at this point is lower. And potential at this point is lower, potential at this point is higher. So in that case, even though the potential at this point, the potential difference across the capacitor, so for example, this is 33.3 volts. but this one could be a potential difference. A potential difference across the inductor could be like negative 5 volts. And also there is a potential difference across the resistor. And the only rule you need to keep is that the only rule is that you need to keep the summation of the potential difference across the resistor and across the inductor and across the capacitor. The summation of all of them, the summation of 3 of them, should be equal to the potential difference across the source. That is the only rule. We do not restrict that the potential difference across the capacitor should be greater or less than the source. That is not restricted. Okay. Okay.